Everyone, I'm Zheng from RIT. I will share our paper AudAgent, Automated Auditing of Private Policy Compliance in AI Agents. So we are focusing on private policy compliance in users' AI agents. Last year, 2025, can be said as the year of AI agents. We have many AI agents like BrowserGPT, Chen, OpenClaw, etc. Compared with LLM, these AI agents can interact with third-party tools or APIs, so they can provide more help to users' daily life. For example, the user may prompt, "Send Bob my latest work report." Then their AI agent will planning for the task using user data, then LM reasoning to arguments, external services to finish this task, and finally return a response to users about the task result. But this actual behavior of their AI agents is invisible to users. So this intransparency will raise many questions on users' data privacy. One question is, does my AI agents only send or disclose the report, but not other sensitive data? For automatic tasks that without user interaction, what is my AI agent actually doing with my sensitive data when I'm not looking at it? And for user privacy preference, what if I want to prohibit the disclosure of my contact information? For these questions, at the AI agents part, they have private policies, they have alignment training and system prompts for user privacy. But in practice, the AI agents can still be all access agents. One typical example is OpenClaw. It can be turned into a malware delivery system, and it's highly recommended that do not use OpenClaw on a carbonate device. So to address these privacy leakages, we want a user-trusted local auditor for privacy compliance. The high-level idea is to have layers to audit the AI agent's data collection, data processing, and data disclosure. So in this paper, we have AudAgent is a local auditor for privacy policy compliance. So we want to audit whether users running AI agents comply with some private policies, including the private policy declared by these AI agents and user-defined private policies. The biggest challenge is that there's a big gap between this high-level and natural language private policies with this low-level unordered data flow in running AI agents. So we need some techniques to bridge them. On the high-level natural language private policy part, first we need to have an auditable privacy policy model. So we extract this type of privacy policy model from the privacy policies. So for each type, we have their collection method, their possession, disclosure concern, and their retention period. Then after this, we have an auditable privacy model. On the running AI agent part, from the unordered data flow, we use a model-guided data annotation. So from user prompts, AI agent's response, their task context, and data direction, and also we monitor the data retention period. So for each data instance, we have their collection methods, processing, disclosure methods, and retention period. In implementation, we use Microsoft procedure with task context for user trustness and efficiency. On this private policy model, we use cross-LM voting for the confidence of a trusted private policy model. So this part does not involve with user trustness. Then this problem is reduced to check whether the actual data behavior comply with the private policy model. There's still one gap left. Is the granularity mismatch between data type and data instance. For example, for contact information, it can be email address, name, etc. For Google, it includes Gmail, Google Ads, etc. So to address this granularity mismatch, we have ontology graph to encode this type, subtype relationship. After this, we can monitor or track each data instance status via automator. So for each data instance, we have an automator to check its transition between collection, processing, and disclosure. And we also track its retention period. So if sometime it does not satisfy the transition concern, we will reject it. One step further, we also have a visualization via HTTP analysis and a WebSocket. So let's see the demo of our tool.
Here we have an agent waiting for prompts, also the associate privacy policies. I've prepared a prompt that asks the agent to search for Bob on the internet. This prompt includes an email address that the user wants to keep private. Let's send the prompt to the agent. Here's the response. At the same time, AudAgent is performing real-time auditing. Let's zoom in a bit so we can see it more clearly. It draws all components and visualizes their interactions as a directed graph as this. Here we can see a violation in disclosure to this third-party tool has been detected. You can also find it here. All of these interactions are also listed in the panel on the right. For example, here is the privacy violation information. And here are the other interactions as well.
Then let's see our findings on highly sensitive data. We found that AI agent's alignment alone is not sufficient to reliably protect highly sensitive data. We observe that AI agents powered by Claude, Gemini, and DeepSeek, they don't refuse to possess highly sensitive data with maybe disguised third-party tools. For example, here is the refusal levels of AI agents backed by different LLMs when they are asked to possess SSN. So let's see this LLMs and the refusal level. The first review level is to refuse to possess with web search tool of SSN. The second review level is to refuse to possess with disguised web search tool. And the third review level is refuse to possess with any other tools. So we can see that GPT-4o can refuse all levels, but other levels like Claude, Gemini, and DeepSeek, when they are used as the backend of AI agents, they cannot refuse all levels. So to address this privacy leakage, we can use AudAgent's built-in rules. Like this example, we can specify data type and specify their and prohibit their data collection, disclosure, etc. So there are two benefits, and in the demonstration, we can provide users with action level visibility into what their AI agents are actually doing. And we can also get highly sensitive data in real time to compensate the gaps in private policies. That's the main step of this paper. Thank you for listening.